Welcome to Study Loop.
Hello again and welcome back. We're looking at chapter 13, problem number 46, and it's a two-part problem, A and B. So let's look at just the A portion of it. So what is the molality of a solution formed by dissolving 1.2 moles of KCl, and that's potassium chloride, in 16.0 moles of water? So let's first talk about what molality is. We normally see it represented by small m, and molality is always the number of moles, and specifically the moles of solvent or solute, divided by the kilograms of solvent. So let's look what we have. We have 1.2 moles of potassium chloride in 16 moles of water. So we know that our solvent is water and our solute is KCl. So we know that we have 1.12 moles of KCl. That's perfect. It's exactly what we're looking for. And now we need kilograms of our solvent. And we see the larger amount is in moles of water, so water is our solvent. The only issue is that it is currently in the wrong units. We have 16.0 moles of water, which is H2O. So what we need it in is kilograms. So let's convert this. We use our periodic table, and we know that 1 mole of water is equal to 16.00 moles per grams of oxygen, and then you have 2 hydrogen, so that ends up being 18.02 grams of H2O. And we got this directly off our periodic table by adding 2 hydrogen and 1 oxygen together, and we know 1 mole is equal to that amount. And now we're in grams, but we still need to be in kilograms. So how many grams do we have per 1 kilogram? We haven't used it in a while, but if we think back to chapter 1, that is 1,000 grams for every kilogram. So let's put this in the calculator. We're going to have 16 times 18.02, and we're going to cross out our moles because they cancel out, and then we're going to divide by 1,000. And that's going to give us, in our calculator, 0.288. And our calculator gives us 0.28832, but we started out with 3 sig figs, so we're going to end at 3 sig figs, and that's going to be our kilograms of water. So let's put it in down here. That's our kilograms of solvent. 0.288 grams of H2O. Perfect. So now we're just going to take our 1.2, divide that by 0.288 in our calculator, and let's see what we get. Perfect. We're going to come up with 3.88 molality. That's perfect. So we've solved one. We solved the molality of the solution. Now we're going to look at the second. Down here at our second. B. So part B. How many grams? So we're solving for how many grams of sulfur must be dissolved in 100 grams of naphthalene to make a 0.12 solution. So let's bring this over to another sheet of paper. All right, so let's look at this. So how many grams is what we're solving for? How many grams of sulfur must be dissolved? So we're still looking at molality. And what is that formula? See if you can remember it. That is going to be small m equals moles of the solute over kilograms of our solvent. So our solvent is, so here's our solvent, 100 grams of naphthalene. So we need it in kilograms. Let's look at that. So let's just take 100 grams and let's convert it to kilograms. So we're going to divide by 1,000 times by 1 kilogram, and that's going to give us 0.1 kilograms of naphthalene. So that's our solvent. So let's see. And to make 0.1 mole solutions, they gave us this amount here, our M. It's 0.2 molality. And we were given our solvent, which is 0.1 kilograms. And what we're solving for is moles of our sulfur, our S8. So perfect. So how do we solve for our unknown here? We get rid of whatever's on the bottom of the equation by timesing it by both sides. 0.1 kilograms. There we are. So these are both going to cancel, and that's going to give us moles of S8. So that's our sulfur. So let's look at this now. So now we have 0.1 times 0.12. So 0.1 times 0.12. In our calculator, that gives us 0.012 moles of sulfur 8. Perfect. So what were we solving for? How many grams? So we're almost there. So to convert moles to grams, we go to the periodic table, and we know for every 1 mole of sulfur 8, let's look at our periodic table. Sulfur is 32.07, and there's 8 sulfurs. So that ends up being 256.56 grams. And let's total that up. So we're going to take 0.12 times 256.56, and that's going to give us exactly what we're looking for, 3.08 grams of S8. So just to recap, when we're looking at molality, we're always looking for moles of the solute over kilograms of the solvent. All right, look forward to seeing you next time.